Okay, if you were working through these, it's going to be best if you work and try and draw the pictures and label them and work through the problems on your own and use this video to check. If you're having any problems, please make sure you see a teacher. Okay, so on this first one, when we draw the picture, we've got two planes traveling, leave the airport at the same time. An hour later, they're 189 kilometers apart. If one plane traveled 168 kilometers and the other plane traveled 240 kilometers, during the hour, find the angle between their flight paths. Okay, so we're going to go ahead and draw the picture. So the angle between the two planes is what we're looking for. So when we set up the law of cosines, we're going to have 189 squared equals 244 squared plus 168 squared minus 202 times 244 times 168 times cosine of theta. When we're solving for theta here, we're going to isolate cosine of theta first. So we're going to subtract the 244 squared and the 168 squared to the other side, and then divide by the factor that's in front of cosine. And you're going to end up with this statement. Okay, if we evaluate the statement on the left-hand side in your calculator, you'll end up getting approximately 0.635. When you take the inverse cosine of both sides to isolate theta, you'll end up with approximately 50.6 degrees. Okay, again, so the next thing we want to do is make sure that we're drawing our pictures. So we have our picture here. The leaning tower is leaning at 4 degrees, which means the angle of the triangle that we're looking at is 90 minus 4, which gives us 86 degrees. That's where we get the 86 there at the bottom. Okay, this is the triangle that we're looking at. We're trying to find the flight path of the bird from the top of the tower down to the food. Since we're looking for the side length across from the angle that we're given, we'll go ahead and set up using law of cosines, and we have x squared equals. This one's rather simple because you're just going to plug all of that into your calculator. Okay, it's when you're testing or anything like this, you have got to show the setup. So this is the part that we're expecting to see on your test. We need to show your setup. We need to show what you get when you evaluate it. Then to get rid of the x squared, you take the square root of both sides. You're going to take the square root of that value, and you get approximately 183 feet. Number 3, it says a triangular lot sits at the corner of two streets that intersect at an angle of 58 degrees. One street side of the lot is 32 meters and the other is 40 meters. How long is the back of the lot? So again, we're going to draw our picture. This is very similar to the one that we just did because the side length that we're looking for is across from the angle that we've been given. So we're going to set it up, plugging into the formula. You're going to evaluate the right-hand side in your calculator and then take the square root of it. And they said to round it to the nearest meter, so we have it at 36 meters. On this last one, they want us to solve the triangle for the missing side and the missing angles. So we're going to go ahead and draw our picture and list out exactly what we're wanting to find. So we're looking for measure of angle y, measure of angle z, and side length x. So using the law of cosines, we have two sides and the included angles, so we're going to go ahead and set up law of cosines solving for x squared. So on this one, you're just going to evaluate the portion on the right in your calculator and take the square root. So we get x equals 37.5. Okay, next we'll go ahead and look for angle y. So if we're using law of cosines to solve for angle y, you could use law of sines too, but we're practicing law of cosines, so that's what I'm going to go ahead and do. So if we're using law of cosines, if we're looking for side length or angle y, we're going to have 15 squared equals. Okay, first thing we need to do is isolate cosine y by subtracting 25 squared and 37.5 squared, and dividing by the -2 times 25 times 375. So we'll evaluate that in our calculator and end up with cosine y equals 0.963. Take the inverse cosine to get the y value by itself, and you'll get 15.6 degrees. Once you have two angles, to find the third angle, you can just subtract from 180, and we get measure of angle Z is 26.4 degrees. If you're having any questions on these, or if you want to look at how to use law of sines once you have that information instead of law of cosines, please get in touch with a teacher.